This conference will now be recorded.
Very good evening, students. Today we'll be discussing previous year's questions from NEET UG papers, and the topic from which I am picking up the questions today is the ray optics, one of the topics which is which seems to be a little bit difficult or fearful topic for the students. Not all, for few students it is really a fearful topic, but this is not at all fearful or very tough topics. Actually, little bit of imagination is required. Other than that, everything comes in formula. Okay. All right. So before I start this ray optics discussion, I'll just recap, or I'll just clarify one question we had discussed from JEE Main paper 2024 April 1st, 4th April. This is 4th April first session paper, and this is the particular question: a cubical arrangement of 12 resistors, each having resistance R, find I. Actually, this is not the correct figure according to the options given over here. I had actually taken the wrong figure. The original figure is this one. Okay, so this is the original figure. Actually, you have to find out the current in this upper. So this particularly through this register you have to find out the current. So that is what we had to do actually. Okay. Otherwise, according to the question, like according to this figure, after finding out the equivalent resistance, we can find out the current I from here as V0 by R. That will be actually 4 by 3R. Okay, this will be the current actually according to this figure. But we had yesterday seen that the whole this circuit can be analyzed if we know the symmetry considerations. So this is the particular symmetry plane which is perpendicular to the terminals. So we can think this as a mirror plane. Okay, mirror plane, this TNMST. So this is a mirror plane. So we had actually neglected these two resistors. So what we had got this so if there is no branching of current over here, so this two will be in series. So 2R and this will be 2R. They are in parallel at this particular ends, because these two ends will be having same potential according to the symmetry relation. So 2 will give you resistor 1, and see you have another 2. So you have resistor 1 here, and another 2 resistors will be here. These branches, these are 2. Okay, so basically you will have 3R on the upper branch, and you look this plane ASB M and this A. This 4 out of this 4 resistances, see here we have these two in series and these two in series. So R2R. So here from here also I'll get 1R. So basically I'll get this as the equivalent resistance as I had solved yesterday. Now look this, the whole figure will be like this. This is R, and you have, see we have actually here. Okay, so this along with that there will be this battery. Okay, this is V0, this is 3R. Okay, these are in parallel combination, so we can find out the current. See, so this is actually a branch. You look here, the upper, I'm actually getting the total resistance over here, but still you can see when the current comes here at this particular point, this will be actually having branched into two. Okay, let us just find out what is resistance, sorry, current through this 3R. Okay, so equivalent resistance anyway we know, right? So this is 3R, so you know this will be current only through this. Okay, only through this R I have to find out. So first of all, let us find out what is I3R. I know the voltage, right, divided by 3R. Okay, this is the current in this 3R. But look, this, there are actually two branches, equal branches. So I'll get current in this whole branch. Like say, this will be one resistance of one, the whole combination, and they are actually in series. See, I have this one out of these two, like these four resistances. I have R here, and I have two more resistances like this. Okay, and this is actually getting connected like this. Okay, like this with the V0, right? Yes, yeah. So this is the thing. Okay, this is the thing. So I'll get actually current in this is I. Okay, up to this I'll get, suppose I prime. Now I have got current in the upper branch, the whole upper branch. See here I prime, I have got V0 by 3R. This is I prime, and this is for the whole branch, like whole this system. See, through this and this two. Okay, if you take the combination. Okay, now this, I can keep this circuit like this also, right? Instead of taking, see, I can keep this like this, and I can keep one resistor here, another resistor here. Okay, I can keep this R, this R, this R, this is R, again this is R, this is R. I can keep like this. So I prime is here. Okay, I prime I am getting V0 by 3R here. Now up to here is V0 by 3R. Now it will actually get branched into two, equal half. Okay, so I'll get I0 by, see, I prime by 2 here, and I prime by 2 in this branch. So this is what is the question. Actually this is, say, I have got, see, this is the equivalent circuit for the upper branch. You can see that. So for which the total resistance is 3R. Okay, so I have, then what is I is actually I prime by, so if this is I prime or I3R, you can say, so I prime by 2, so V0 by 6R. Okay, so this will be the actually current in the specified register. Okay, you look this register, we had to find out the current in this register. Okay, through this register. Okay, so I'm sorry for choosing the wrong figure yesterday, and we got confused because of that only. Okay, so according to the question, like according to the figure, we will not be able to match any option. Okay, but if I take that figure, the actual figure, then we will be able to get the right answer, and that is actually this one, V0 by 6R. All right, so I had clarified this. Now I'll go to the ray optics part, which I said I have picked up the questions from NEET papers like 2023 to 2022, 2021, and 2020. Sorry, 2019. I have picked up some questions from there. Okay, so let me solve one by one. I'll explain as uh, like when I'm going to solve this. So the first question is two thin lenses are of same. This is same focal length. Same focal length f, but one is convex and another one is concave. When they are placed in contact with each other, the equivalent focal length of the combination. See, that means, you know, I have this one, okay, equal, both have equal focal length. So I have another one is concave, another one is convex. That is what is the question. If I keep them in contact, you can just take a combination of two lenses. One is concave, another one is convex one, and then you just, these are thin lenses, you just find out the equivalent focal length. We know the power in the combination of thin lenses will be additive, so p1 plus p2 I can write. Power is what? Power I know. For this one, power will be positive, and this, so I can say both of them will have the same power, right? For convex it is positive, and for concave it is negative power. Since both of them are having same focal length, power is actually inverse of focal length, right? So look, this is 0. Since both of them are having the same focal length, the power of the combination will be 0 power. And we know this is, say, equivalent. So we know the focal length, equivalent focal length will be inverse of power equivalent, and it is, say, 1/0. Generally we take this as infinity. Okay, so option D will be the correct answer for this question. This was so simple question. Now we'll take up this question. This is also a very good question. So in the figure shown here, what is the equivalent focal length of combination of lenses? Assume that all layers are thin. All layers are thin. Okay, you can take this figure, so you can see, first observe the figure. See, this is a liquid, okay, or a medium, inside which this lens is, convex lens is immersed. You just take this as a liquid, some glycerin or something like that, and this is a convex lens of made of glass, which has refractive index 1.5. Now when you immerse like this and keep fixed, then you can see very closely I have actually three thin lenses in combination. Three thin lenses in combination. One is this one. Okay, you look this one, which is made of just liquid. That means, you know, you have three lens, and see, this is also another lens. Okay, I'm just drawing it here. So this is one lens. This has refractive index 1.6. That means the lens is made of material which has refractive index mu. We can take that. Now you have this one. Okay, this has mu 1.5. That means the lens, original lens which you have dipped into the liquid, and another lens you can see this one. So in this case, all of them have the same radius of curvature and all the faces. See, for this particular lens, I have R1 and R2 equal to some R, that is 20 centimeter. So radius of curvature for this one, this is actually plano concave. So generally we have two curvatures or two part of like two curved part of two different spheres for a lens, right? For this, we take this as R1. This radius of curvature of this surface is taken as R1, and this surface we take as R2. In case of concave, it is actually ulta or just opposite. This we take as R1 and this we take as R2. Okay. Now for this lens, you look, this R1 is infinite, and for this lens R2 is infinite. Okay, and rest of the things are as it is. If you know the lens maker's formula, we know, right? We know this formula, 1 over f is equal to mu minus, mu is the refractive index of the medium, sorry, the material with which the lens has been made, and then refractive index of the medium, in this case AR, we have to take for each of them. Okay, for each of them you can take, okay, AR is the medium, and then this is 1 over R1 minus 1 over R2. This is the formula generally. Okay, I'm just writing this as mu 0 divided by, or mu medium divided by mu 0, like this. This is the full formula. So in this case, actually mu 0 is 1. So what I'll get for this lens, let us take that as f1. Let me take focal length of this one is f1, focal length of this is f2, and focal length of this is f3. So 1 over f means power, right? So let us write this power of p1, p2, and this is p3. So the p equivalent actually will be p1 plus p2 plus p3, right, with the proper sign of p. Let me tell you here what is f1. Let us find out for this. F1 will be, see, mu is 1.6 minus 1 divided by 1 is same, and then you have infinite minus 1 by R2. R2 is same as this 20, so you will get this as minus 0.6 divided by 20. Okay, this I'll get. But this one, for this f3, sorry, this is f3. So f3, what you get, sorry, this is 1 over f3. 1 over f3, this is 1 over f1. 1 over f3, what will get? Will get this mu minus 1 is 0.6 anyway, into, see, this R2 is infinite, whereas R1 is having certain value. Okay, R1 has got some value, and see here R2 is actually infinite, isn't it? Sorry, negative, right? R2 is negative here. R1, sorry, R1 is negative here. So for this lens, let me tell you here, for this particular lens, I get 1 over minus R1 minus infinity. Okay, so this 1 over 1 minus infinity, sorry, minus 1 over infinity is 0. So this you will get minus of R1 is 0.6, sorry, 0.6 by 20 only. So R1 is also 20. So I get what? I get minus 0.6 by 20. Okay. I think I am just doing a lot of uh, calculation in a very less space. But what I'm trying to make you understand is that both of these two will have same power, 1 over focal length power with same sign, okay, negative sign. I have got, see, I have got same thing here. So for this lens, for the convex lens, I get 1 over f2 is equal to 0.5, that is mu minus 1. Mu is 1.5 and minus 1, that means 0.5 whole into R1 and R2. See, R1 will take positive this side, so it will be additive. So 2 by 20. So what I get 1 over 20 over here. Okay, so I get, see, 1 over 20, these are actually power. So directly I can write this, this is 0.6 by 20 minus 0.6 by 20. I'm sorry, this is for P3. It is 1 over 20 with a positive sign, 1 over 20, and this is again 0.6 by 20. So this will give you, see, this will give you minus 0.2 divided by 20, right? That means, you know, this is minus 2 by 200, which is 1 over focal length, equivalent focal length will be minus 1 over 100. That means focal length will be minus 100 centimeter. So option 3 will be the correct answer for this question. So I hope guys you have understood this. If you don't like my calculations, my way of doing calculations, you just do your own calculation in a very cool mind, in a very fresh page. Okay, so but this is the concept. Okay, you have to consider 3 different lenses, and see, concave lenses will have the R1 infinity, and in second concave lens you have R2 infinity. Okay, that is the point I just wanted to say. All right, so let us go to the next problem again. So this problem is, see, this is also a very interesting problem and very similar to the one which we have done. See, concave length of focal length 25 centimeter sandwiched between two convex lenses, each of focal length 40 centimeter, the power in diopter in the of the combination. See, here it is very simple. I will just take combination of 3 lenses we had done for the previous cases also. Okay, so all of them will be having the same focal length. No, this has 40 centimeter, this has 40 centimeter, and this has 25 centimeter. So power will be additive, as you know. Power will be P1 plus P2 plus P3, right? These are equivalent powers. Okay, so power, let us find out what these are. Over 40. So you can say 2 over 40 minus 1 over 25. Okay, so that means 1 over 20 minus 25. So this will give you, this is actually centimeter. So this is in centimeter, but diopter is per meter. Okay, per meter means this will be 1 actually. Okay, this will be 1. 1 over 100 centimeter means 1 meter. Okay, per meter is actually diameter. Diameter means actually per meter, some value per meter. Okay, this is the diameter unit, so it will be 1. Let us go to the next point, next problem. So this problem is also very simple problem. If you can understand this, say there is a beam of light is incident. Okay, so a beam of light incident vertically on a glass slab. Okay, so you can just take this as uniform glass slab, uniform thickness. It is some thickness D, it is saying, I think. Okay, let me take this thickness as D. A beam of light incident vertically on a glass slab of thickness T is equal to 1 centimeter. And refractive index of this is also known, that is 1.5 glass means a fraction of light. See, when it vertically incidents like this, okay, and it is said that a fraction of light reflected from the front surface, okay, from the front surface, from here itself, okay, some reflection happens, okay, and as you know, this will be normally going out, okay, some fraction is going, so this is actually fraction A. Okay, now while the another fraction B enters the slabs, okay, as you know, it will be entering. After entering, it will actually, it will deviate, but it will just come up to here, okay, come up to here, then this is fraction B, and then it emerges. It will emerge actually in case of normal incidence, it will be emerging like this itself, okay, it will be emerging like this itself. Oh, I see. Let me finish the sentence. Enters the slabs and emerges after reflection from the back surface. See, this is actually getting reflected from the back surface, okay, this B portion reflected back, and then it is actually emerging, okay, this is also normal and emerging out, okay, fraction B. So they are actually going in the same path, right, A and B, but one has reflected back initially itself, the other one has gone in all the way up to the bottom face of the slab, and then it will refract 2 times, once here, 3 times actually, once here, once here, and then last time here, and then come out. So there will be obviously a time delay. You have to find out the time delay in second, and there are options like this. So what is happening here? The light, or the fraction of light which is going up to this bottom face, that is fraction B, it has to actually cross this thickness T twice. After that, it will be coming back this, cross this slab. So how much thickness it has to cross? So 2T. So T is 1 centimeter. So 2 centimeter it has to cross. So this much traveling extra, okay, before emerging. So obviously there will be a difference or delay in time. So what is the time? I know the time. See, suppose it starts with t is equal to 0, then it goes here and come back. If I say that time is t, let us take this thickness. Okay, so anyway, if I take that time is capital T, capital T, then capital T plus 0, this is the total time it takes to image out. We have to find out what is this capital T time. That is time to cross this glass slab twice by the fraction of light b. So we know light inside a medium will be different than in vacuum, right? We know refractive index is equal to c by v. So what will be the speed of light in the medium? V is equal to c by mu. Let us find out that velocity. So this is c. C is actually 3 to 10 to the power 8 meter per second, and mu is 1.5. So you will get the speed of the light inside the medium as 2 into 10 to the power 8 meter per second. So I have got the speed. Then how much time it takes to cross twice? That will be capital T is equal to d by v. D we have got 2 centimeter, that is 10 to the power minus 2 divided by 2 into 10 to the power 8 meter per second. So this two will cancel each other. This will be 10 to the power minus 10 second. So option A will be the correct answer for this question. Okay. All right. So we have another question. A biconvex lens has radii of curvature. Biconvex. Okay, this is the biconvex lens. Each surface are 1 to 4 focal glass, that is mu is 1.5. The power of the lens, you have to find out. What is the power of the lens? See here, we know 1 over f from, okay, in this case 1 over 20, right? 1 over 20. So this is per centimeter. I have to find out in diopter. Okay, power in diopter. So we have to multiply 100 here to make it in meter, per meter. Okay, so this will be in diopter. Five diopter. This was so simple. Unless you understand that the unit is different, that you have to convert by multiplying 100. Now this question, this is also a very simple question. Find the value of angle of emergence from the prism given below for the incident ray shown. The refractive index of the medium index of the glass is root 3, root over 3. Let me show you. So this is suppose a refracting phase, and this is another one refracting phase. You look here, what is happening. See, this is actually normal incidence. So in any case, normal incidence, it will actually pass through normally. So this is the path. So this is the path. So this is 90 degree. You look this total triangle. So this is 60, this is 90, this must be 30 degree, right? And this is 90, this is 30, so this must be 60 degree. So what will be the angle of incidence at this surface? Suppose this is AB and this is C. So this AB surface, the angle of incidence will be with the normal. This is actually 30. So this is the geometry you have to imagine. Otherwise, nothing was there. Now we'll be applying Snell's law. See, for the surface AB will apply Snell's law. So angle of incidence, I'll take this one. So N1, that means you know the mu refractive index root over 3 sine I. This is equal to see here emergent ray. I have denoted R, and here you know refractive index is 1. So sine I. So this is actually sine R is equal to root 3 by 2, right? Root 3 by 2, right? So sine 60 degree is actually root 3 by 2. So this implies R will be 60 degree. So angle of emergence will be 60 degree. Along the same axis, distance D between them. If the parallel beam of light A leaves A as parallel beam between the two lenses. So the question says you have a convex length of focal length 20 centimeter. Okay, and then you have for both of okay. So this has focal length 5. Now they are separated center to center distance. D. Now see one ray, parallel rays coming like this. See if I say the 20. See now these are A. So this is lens A. This is lens B. See these parallel rays after refraction they will actually meet at the focus, right? And see the refracted rays will create a point image, and that image will actually act as the object for this. Okay, fine. So there was some network issue, so that's why there was mute. The sound was mute. Now it is okay. I'm continuing again. So I have another lens like this. Okay, both of them are having the same focal length f and f. They're kept coaxially, okay, such that the focal length of the combination will be, so in this situation focal length of the combination will be f1. So that is how much? That is, see, this is 1 over f1 is equal to 1 over f1 plus 1 over f2, okay, or 2 by f, 2 by f. So f1 is equal to f by 2. So this is what we have got. Now second thing is, when the space between them is filled with glycerin, now look, it is filled with glycerin. So what will happen, you know, this place, you look, this place will act as another concave lens. So I have now combination of three lenses. One is this convex lens, this concave lens, okay, plus this one, another convex lens. This I don't know what is the this focal length. I don't know this focal length. Okay, so focal length, I have to find out what is this focal length. Let us say that there is a prime, and all of them will have actually the same radii of curvature. So let me find out. Say for this, f is actually 1 over f is mu minus 1. Okay, mu minus 1, same refractive index. Okay, so I see. So the glycerin also has the same refractive index, and all of them have the same radii of curvature also. So what I'll get? See then, focal length for this one will be, see, because this is my mu minus 1, and then I'll have 1 over this plus this R2. Okay, so finally what I'll get, I'll just take the minus out from here. So then R1 minus R2, right? So this will give you actually minus F. Okay, focal length minus F. For this situation, let us find out. So I have one lens, convex, concave with minus F plus again F. So in the combination, I have 1 by F2 is equal to 1 by F plus 1 by F minus 1 by F. So these two will actually cancel each other. So F2, sorry, this 2F, sorry, F2 will be only F. So I have to find out the ratio of F1 by F2, that is 2F, sorry, F by 2, and this is F. Yeah, am I right? Yes, F by 2 by this. Okay, so what I get? I get F1 by F2 as 1 by 2. That means F1 is to F2 is equal to 1 is to 2. This will be the answer, and look, this option is there. So the option C will be the correct answer for this question. So with this, I'll stop it here for today. Okay, so thank you for your patience. Bye for today.